Hello guys, today I'm gonna show you how to create the pretty much simple save system for narrative adventure game. As you can see from the picture, here we have the pipeline how our save system will work. For instance, we can have multiple levels. Each level can have some kind of checkpoints. As you can see, it's direct interaction save and area of effect checkpoint. So, as it goes from the name, direct interaction means we need to interact it directly with moving our mouse over the interactable object, then pressing the proper key. As for the area of effect checkpoint, we just need to step inside the predefined area. Also, as you can see, we have the transition to the next level. So, how it works? First of all, we are spawned in the basic level. Then we are progressing through the level and saving with the help of checkpoints. When we reach the proper area of our level, we need to save our progress and have transition to the next level. So this way it will work. Also, as you can see, we have some points that we need to achieve. First of all, we need to save the transform and last visit checkpoint, so when we launch our game one more time, we need to be located in our last position, in our last level. Next, we need to save the progress of our inventory and our attributes. By inventory I mean we need to save all our items and our last selected item. We also need to synchronize world interactable objects. So when we pick some object and save our game, then we relaunch our game. The object needs to be in our inventory and it shouldn't exist in the world because it was picked. Also, we need to save the weather and time because we have the dynamic weather system. So when we save our progress and relaunch our game, these features should be synchronized too. As you can see, I don't have the multiple save slots because in my case I don't need it because I'm developing the adventure game, which will actually have some kind of save system as roguelike games, maybe. But if you want, I can expand it and create a tutorial for multiple save game slots, so you can choose between which save to load. But this tutorial will show you the basic concept and idea how it should work, and you can follow it to create more expandable system by yourself. So let's get started. Before we start, I'd like to notice that you actually should watch my previous tutorial on interaction system, consumable system, so there won't be any misunderstanding when I'll explain you how my save system will work. Actually, I will show you the main concept so you can recreate the basic behavior yourself, but to fully recreate the pipeline, as I said, you should watch my tutorials. It will help. So, first of all, let's begin with the simple items. Let's go to our class. It's BP save game, the class that inherits from the save game. Here we need to add the game data. It's the structure type of asset. As you can see, it's structure which actually holds two more structures, player and level. For this, we need to create them. So first of all, let's create structure that I call level data. Here you can see I have some attributes that I need to store during my game. First of is called levels and transform. It's the map which stores string and transform. So basically it stands for each level will store our position of our player, so we can load and play from our last checkpoint. Also, it has levels time. It's also map, string and float type. For each level we store the time we saved. Checkpoint stands for last checkpoint. It's a simple string and we need it to create some kind of logic that I will show you a little bit later. Also, picked. I'm sorry guys for the naming. I really don't know how to name it more precisely. As for me, I like these kind of names. You guys just create your own, so you will know how, I'm sorry guys, just create your own naming for these attributes. For picked, I use string array, and I need this to store every item that I will pick in my world, and it's actually needed for my inventory component to synchronize whether this element should exist in inventory or and which object should not exist in the world when we load our game. Phew. Now, player data. It's also structure. Here you can see I store some basic attributes. Right now I have health and stamina, but I think I don't need them actually in my game in future. But for the sake of tutorial, I'll show that save system can actually store any kind of data. Just need to implement the basic pipeline and it will work. Also, inventory. It's map for BP consumable base class and integer. And selected. It's also BP consumable base class. Why I choose class? The pipeline for restoring inventory when I load the game is simple. As my inventory works in the following way, when I actually pick some element in the world, I don't store objects because it's overwhelming logic. It's not necessary. We just need to have one kind of object placed somewhere in the world, and we use it as a reference for the logic that we are actually executing through this object. And integer is just for iteration, for the sake of having multiple kind of our objects. So when we use the one, we are actually decreasing the size we have in our inventory, and when the size of our inventory of our object equals 0, we basically clear it. So class is very unique kind of data for restoring information, because as you know, when we place object in the world, it has the different display name and object name, but the class will always be the same. So you can recreate actually the object or respawn it if you have the valid class. I'll show you how it will work later. Just go as I tell you. You will see that this logic works perfectly. And of course, the master structure. It's actually the structure that holds our newly created structures, level data and player data. So when you create these two, you can actually create the master and select our custom player and level data structures. So when we are done with this, as you can see, actually only health and stamina has some default values, because all of games has 100 in each attribute. Almost all the games has these values as the default values for the attributes, but for all other we need them to be null, so we will actually be adding elements to them. Now let's go back to the save game blueprint and, as I said earlier, create game data and select variable type for our master custom structure. Save it, and now we can close these assets and let's continue. Now let's take a quick look at the interaction Hud widget. As you know from the previous tutorials, when you are selecting interactable object in the world by moving mouse over it, it shows which key to press and the proper action text for the action: interact, hold, press, and so on. So as our checkpoint, in my case, will be the children from the interactable base class, as you can see here, I have the system that will, not will, but actually know with what kind of interactable object I'm working with directly. So to make some quick changes for the proper action text when I interact with it, I just need to open interactable type enumeration. Here you can see I have interactable, consumable, and now it's checkpoint. Add it here, and when I open Hud interaction widget, in the event pre-construct, here in switching logic, now I have checkpoint exposed, and I use key action element of my widget let me see, it's the text. Yes, this one. So when I interact with the object directly, if it's checkpoint, I set the proper text, also it's just safe. So as you saw from the demo, it works pretty much well. And for the update progress bar, I use the same kind of logic for checkpoint as I use it in interactable type. In my case, I'd like to save by holding the key, not just by clicking on it, because my game will have some hardcore elements, so you need to actually decide or make the proper choices in quick time. So holding the key will actually make it a little bit nervous and scary during the gameplay. So just like this. And when we're done with our HUD interaction widget, now it's not the actually main type of tutorial, not so important, just to make the game look more pretty, nothing else. So if you don't have it, you can skip it, and you can actually go with the interaction system, not interaction system, guys, I apologize, it's around 11 o'clock in the evening and I'm a little bit tired. But nevertheless, if you want to create a checkpoint with area of effect, this can be skipped. Now, BP checkpoint, as I said, is the class that inherits from interactable base. It's the Uber class that actually holds three types of interaction to save the game progress: direct interaction, area of effect interaction, and it also stands for the transition between our levels. It's the endpoint of our level. So, in case you don't want to recreate the interactable system, you can actually just go with this kind of logic here. As you can see, I have sphere collision. Collision preset is actually custom. We need to ignore everything, but we need to overlap with the pawn. So when we have it, we can actually select our sphere collision. Now in details panel, look for events tab and select on component begin overlap. Then we need to check whether we are interacting or overlapping with the proper class of actor. So it will prevent, for instance, if you have the IE or NPCs, from saving the game when they interact when they actually interact with this checkpoint. So we need to cast to our, in my case it's player character, in your case it can be third person character, and so on. So whether the cast goes, it doesn't fail. Here you can see I have save game data and create save widget. This is not necessary, it just for the sake of prettiness of how your game will look. As you saw from the demo in the beginning of the tutorial, this action stands for popping up the icon of the diskette that actually stands for the save progress. And for this part, let's go back to interface we created earlier. In case you don't have it, you need to create one. I call it VPI_game instance. And here we have some methods or functions. As for this tutorial, we need to have save game data, next load game data that will actually return the structure of our game data we created earlier. We needed to restore the progress when we load our game, and one more function, it's reset game data. In case, I will show it later, if you have the advanced, that I'd like to call main menu, so you can actually pause your game. Next, you can go back to your screen, start screen, and then if you don't like to continue the game with your project, with your progress, you can actually overwrite it with the new game. So reset game data stands for rewriting and begin the new game. When you have game instance interface, you actually need to have game instance class, which actually has implemented game instance interface itself. So in BP game instance, we need to declare or implement our events we created in our game instance interface: save game, load game, and reset game data. As for the checkpoint, if you talk about the overlapping logic, here we just need to call save game data event, and what I like the most in interfaces that you don't need to check whether some element is valid. You should create your logic the way that you don't need to check whether something is valid or not in most cases. So this kind of logic will actually simplify the way we need to get game instance cast to our game instance, then call the event. So casting is, we withdraw casting, we use interfaces. So event save game data. First, let's talk about prepare game data slot and load game data. When game instance is initialized, it's the first element which actually stands when the game launches, and it lasts during the whole gameplay. So it will close when the application is closed. Here you can see I have the sequence. So the first element is called we prepare setting slot. It's from the previous tutorial. Next, we are preparing game data slot. For this, we have game data slot string variable. We check whether our game slot exists. Make sure to select the proper string inside your string variable. So this name stands for the name of your saved data on your hard drive. So whether game slot exists, we just call load game data function. Whether it's not, we need to create the one and save it to our local reference variable. The variable type is bp save game. So you can notice, for instance, we have the same class for save game, but different reference variables for our settings and our game data. Now let's go to load game data. It's under interface because it has the return value, and here we load game from slot with our game data string variable. Then we cast to our save game class, set it as our local variable reference. Then we expose, actually drag away and search for game data and use it for the return node. So when we load our game data, our structure can be used to restore our progress. Now, when we save our game, we actually load our previously stored progress, our data, so we can actually add the new elements to our previous game data in case we need in future to have some fast travels. So it's like in Bloodborne game, when we go to the lantern and fire it, we can actually go some areas back or forth, and they need to be synchronized for all elements in the world. So for this kind of logic, we need to, as I said, load previously data and add the new one to our previous one. So here I have the local picked list. When we create the game data here, right after the loading, we can break on the structure. As you can see, I don't use unnecessary pins, so the visual look is much more clear. And I use my previously stored picked elements in the world and set my local version with the values from my array here. The same for levels and transform, the same for levels and time list. So object, level and our last transform, level and time. As you know from my tutorial on the dynamic weather, the weather actually works with the curves, and curve defines which type of weather is on very proper, very unique time. So when I have some specific hour or time, the weather actually depends on it. Next, this node can be called from any blueprint, and we will use it very often. We store it, the current level name, as our current level local variable. Next, we are going through the logic for actually saving our inventory. So in case you don't have it, you can skip this part and just go like this. But let's actually talk about storing our inventory. I'm iterating through all the objects that are placed in the level. In my case, inventory consists only with consumable base class. Now I'm iterating through all of them, and let's open it and check what do we have in picked and object name. So this will actually go for our picked list. Let's see this, and consumable base class. On the event begin play, I use get current level name. Next, I have some pretty unique logic because each level has unique name, but objects can have same names. So there will be name. It can cause naming errors. So in case to prevent it, you can go with this kind of logic. You append the level name before the object name and store it as the object name. So each level will have its own unique name for each element, each consumable. Next, the new functions that I have are pick item and synchronize data. On the event begin play, right after I store the object name, I use synchronize data function. What it does is actually loads our game data. Next, it uses the picked array, and we check whether our object, actually object name, contains in our picked array. Whether it's true, we actually set actor enable collision to false, so we stop interacting with this element, then we hide it in world and set it as picked. So when we restore our inventory, we will check whether it contains in our inventory and whether it's picked. So if those two conditions are true, the element should not be visible in our world. The reason why we don't destroy it is just for the sake, in case we need to have some restoring, or maybe restoring objects. For instance, when we pick something and you can have the cooldown for instance 30 seconds, and the element should restore. So this will actually help it. Now, as you can see, consumable base class now looks pretty much more clear. If we take a look at the previous revision, just wait. Not this one, I'm sorry guys. Maybe this one. Yes. Let's go to maybe event graph, yeah. This, how it looked 2 revisions earlier, and this, on your right, how it looks now. As you can see, I had set lifespan, then I destroyed my elements, so right now logic is much more better. So on event main body, when it fires, it's actually we pick some element. Let me just show you the main principle. So when we get our current consumable and whether it's valid, we check our maximum quantity and our current quantity. It's also from the previous tutorials. So whether it's true, we just update our log widget. Whether it's false, we use pick item function. Or whether it's not valid, we also use our pick item function. And that's it. What stands for pick item function? We use add to inventory interaction. It's actually the action on the function through the interaction system interface. So when we pick something, it's actually stored in our inventory. Then the same as it was with our synchronized function. Set actor collision enabled to false, set actor hidden in game true, and picked also true. Now let me just show you one more time how it was in the previous revision. So this doesn't change. There was update log widget event. If we had false, there was add to inventory at set lifetime. Now it's pick item, and as you saw, it's actually the same add to inventory, but for the sake of restoring elements, I don't use set lifespan, I just hid it and make it pickable. And whether it's not valid, you can see the same logic, set collision, set visibility, but here I had set actor hidden and attached to the actor, but actually I don't need to go with all of these objects attached to myself. They just can be hidden and left where they are actually located to restore, and also add to inventory. So pick item function just makes it more clear. Now back to game instance. So when we are iterating through our consumable base class, whether it's picked, we add it to our picked list. And we actually extract object name. So our picked list now consists of elements with a very unique names. The name of the level and name of the item itself. Whether it's not picked, we just don't need it to store. We only store our picked items. Then on complete, this part goes for the weather synchronize. I created get weather system function in my function library. What it does, it's actually get all actor for class, and weather system will always be instanced by one element in my world, so I can get the 0 element in the array and the return node, which actually returns weather element, weather system. So through weather system, I can have the current time added to levels time list as the value for the key, and key stands for current level. In case you don't have dynamic weather system, you can skip this, and implementing synchronization between save system and weather system will actually be a little bit later. So please stay with me. Next, current level goes for the level and transform list, and for the transform, I use getPlayCharacter and use its transform to store my position in the world. Here, next I have getPlayData. It's actually the function implemented in playCharacter, and I call it through the BPI playCharacter. It's the interface for playCharacter. In case you don't have it, please create it, or you can use getPlayCharacter, cast to your playCharacter, for instance, third-person character, and then you can call for the function. In my case, this function returns play data. It's the structure, not game data structure, but the child one, player data. And in my playCharacter, I have function, this one. So when you create it through the interface, you can actually select it in your interface. It will be marked with the blue one, this one. So what I do, just for, actually this part goes for the inventory and this for the attributes. In case you don't have inventory, you can skip this and go with this one. But let me tell you. So I use inventory component, then I use consumable object list, the array, and iterate through it. Then I check whether it's valid and whether current quantity of my object doesn't equal 0. So I don't need to restore the element with 0 elements. I can't use it. I can use only valid and only valid elements. So whether it's valid and current quantity doesn't equal 0, this inventory is actually the local variable here. I don't need to have it in my common variables. It's just the temporal map, the map that consists of consumable base class and integer. So I use getClass from my consumable base class as the key and the current quantity as the value for this key. And on complete, I use make player data structure. You can just press right mouse button and in the context menu search for make player data. So I store inventory, current health and current stamina, and also from the inventory component I select active consumable and get its class as the selected one. So I store the last selected element that I have in my quick action. So I don't need to open my Pi menu, select something and then only use it. It is selected right now. Also, how to implement synchronization between inventory component will be a little bit later in this video. So let's keep going. Now, let's go back to game instance. So we use getPlayData and we also make level data and game data structures the same way that I show you right 10 seconds left. Just search for make level data or game data and we use our picked list, levels times list, levels transform list, and we use current level as our last checkpoint. Then we make game data with the player data and this one, and we need to set or overwrite the game data we had in save game data object the one it's actually the save game class I showed you earlier, and this one is created right here in prepare game data save slot, this way. So when we overwrite it, we actually use save game to slot as game save game object, save game data object we created, and our game data slot as the slot name. So this kind of logic will work in any blueprint you create. So you can have, not like I have Uber checkpoint, but you can create some different blueprints only for overlapping logic, only for direct interaction object, and so on. So just by get game instance and use save game data, it will actually create saved data for your game. And actually the whole save game data logic. So the left part of the video will show you the pipeline, how to implement the behavior for synchronization and restoring the elements when you have some save game data. So let's continue. Now guys, let's talk a little bit about my Uber checkpoint class. Right now you can see that I have an enumeration which is called eCheckpoint type, and it has 3 different attributes: direct, area of effect, and endpoint. Each attribute is for the particular interaction type. Direct means hovering mouse over an object to interact, area of effect to step inside the proper area, and endpoint means saving and transitioning to another level. So I implement this one, so I can choose what kind of checkpoint I need to have on my level. So on my level, in the world outliner, right now you can see that I have the endpoint and the area of effect. Actually, it's those two elements. They even have their own unique visual style. For instance, for the endpoint, I don't need to visualize the area of effect, but I have the model, and I also have the name of the level I need to transfer to. As for the area of effect, it just has only scale area, so it decides the area in which I need to step inside to have the same data. So now let's go inside the checkpoint and I'll show you the rest of the setup. So it has static mesh component with the component tag interaction. I need this one because the main implementation in interactable base class has the logic which actually checks whether I have this tag. So if it's so, I can hover mouse over a static mesh and it will be outlined and I can actually interact with it. So please do the same. Well, I think as for the area of effect, I demonstrate you everything. So now let's see the variables they have. As you can see, I have the boolean type, it's be editor, and the logic behind this is pretty much simple. When I develop a game, I don't need to corrupt the saved data, because the logic for the whole gameplay of the actual game is to start the game from the main menu. It's at the transition level, the blank level. So in case when I open the level, for instance, not the main menu, but the chapter 1, chapter 2, and so on, each time player start spawns my character, it is saved. So to prevent the unnecessary save moments, I use simple logic, whether it's not editor, so the boolean set to false, I actually disable collision of the area of effect. The same logic goes here, but for the direct interaction. So whether it's editor, I don't need to have any interaction with the endpoint or direct save. But when I'm done with developing the level and I want to have the proper save ability, I need to select my checkpoints, and if they have editor checked, I need to uncheck them and save my level. So when I package the game, everything will work fine. I find this solution the most easier way how to deal with loading different levels during the editor, actually during the developing the game, instead of having some very complex workaround how to deal with save data inside the Unreal Engine. So you just need to be more careful with this kind of logic, but when you used to work with this, there will be no problem for you. As for me, I can keep my attention to all of the checkbox for all checkpoints that I have in my level. So, what's next? Checkpoint type. It's the enumeration that I demonstrated earlier, and as you can see, for this level, checkpoint type for this little box is endpoint, so it means when I interact with it, I will transfer to another level, to the chapter 0.2. And you can see that I actually need to type the name, because for some reason, when you have to transition to another level by using open level by object reference, there is some kind of bug, so the name that I store actually is corrupted. So when I use the string open level by name, everything works fine. If you have another option how to deal with this situation, please let me know. So, as you can see, if the editor is false, I have the switch on enumeration type logic. So for the endpoint in direct interaction, I set collision to area of effect to no collision, and when I need to have only overlapping logic, I use query only for the sphere collision. As for the direct interacting, I leave area of effect blank, and for direct I use save game data to the interface of game instance. As for endpoint, I use the same logic, but also open level by name. I'm sorry. As you can see, level is also instance editable variable. It's string type. By default, level name is blank, so you need to provide the name yourself. Now, this logic is for here and here, actually for displaying the icon that the process of saving data actually works. So I'll show you right in a minute. Now let's go to the construction script and see the logic for visual feedback that I have here. So for instance, if I change checkpoint type to direct one, you can see that the debug sphere is gone. If I use area of effect, now it is visible. The same goes for the endpoint and direct. So right now I have the model here. So when I check area of effect, it's gone. If it's point, it also visible. So basically, switch on checkpoint type. If it's direct and endpoint, the area of effect should be, its visibility should be set to false, and static mesh is set by the model that I have here. As you can see, it is also instance editable, so I can choose any model to visualize how my checkpoint will look. If it's area of effect, I need to bring back the visibility of area of effect sphere collision, then set sphere radius to the size that I prefer, and also set visibility both to widget and static mesh of my checkpoint to false. So I don't have any model, and when I don't see any widget, I cannot interact with the object. And that's all for the checkpoint, and we can move on, and I'll show you here this part of logic for displaying the icon of saving progress. I have this kind of widget. It's simple icon with some adjustments for the anchor and size here. Image goes here. As you can see in the graph, there is some simple logic. Also, you can notice that I have the animation. It is called icon pulse, and it has some basic popping up animation. So to make this, you need to add track and select the icon that you have on your own. Then, when you have the track, you can select your element, and on track, press the mouse key and select what to change. Here I change the transform. As you can see, I only change the scale during the animation. When I have 0, I use scale 1. Then on 0.5 it's 0.75 and back to 1. So it pops up. Well, in the graph here on the event construct, I use timer for actually play the animation, and then right after 1 second I destroy my widget. So I don't need any logic for any more logic for controlling how to destroy the widget. It's automatically. So right after set timer by event, I have play animation and use icon pulse as the reference. You can see that number of loops set to 1 and playback speed. For my case, I choose 2, so it pops up a little bit faster. And that's it for this widget. Now, as you can see, it's the interface message to create the widget. So we need to open interaction system interface. And you can see I have created create save widget function. Then in player controller, I have this type of logic. Here I use event create save widget. Then I create the widget Hud save game, the one I demonstrate you right minute away. Then I actually save it to the default, not default, for the local reference and add to viewport. That's it. So when I overlap or have the direct interaction with the checkpoint, it triggers this event in the player controller, which actually spawns the widget that you saw. And right after 1 second, it destroys. So now we are done with the checkpoint, so let's move on. Now let's go to the inventory component and I'll show you how to synchronize and make the inventory work with our save system. You can see that it has some changes from the last time you saw it. These elements actually look the same, but we have some logic here and here. So first of all, let's begin with event begin play. Here I use set timer by event. It's looping and it calls the custom event that I call check inventory widgets. I need this one to have the information whether my widgets, the widget for currently selected item and pie menu are actually created. So I can send the information when I need to select any item or when I need to interact with my consumable, so it will work in the proper way. For this, I have created 2 more interface functions. The one is called get pie menu widget, the second one get active consumable widget. So we need to open interaction system interface, and as you can see, get pie menu widget actually returns Hud pie menu widget, and get active consumable widget, the same logic, but it returns Hud consumable. Those who didn't or haven't seen my previous tutorials, now you can actually just close the video and decide by yourself whether to see it or not. So let's go back to player controller and I'll show you these 2 functions. So basically the logic for creating consumable widget and pie menu widget is right here, So for those who have seen it, the function for returning the widget looks this way. Just need to provide the proper reference link here and here. Now we can close it and move next. So I check every 0.2 seconds whether my elements are valid. So when they are valid, I clear the invalidate timer by handle to stop ticking logic. Then I use restore inventory function. What it does, actually, it loads the stored data from our save game, unpacks it, and actually recreates the elements we need to have in our inventory, so we can actually find the logic inside our object. So load game data, then break the whole game data, and I use only player structure to actually store it in the local variable. Then I break player data and search for inventory. Then in the inventory I use keys for the map to actually have the class array, and class array is it's actually the same that we need to use in our consumable class list. The logic which fires events add to inventory and remove from inventory. So then I iterate through this array, and whether I find the quantity for my class, I mean not quantity, whether my array has, whether my keys have the values for them. So whether it's true, I spawn an actor. Actually, this actor is the array element, the class that I store in the array. Basically, I store only consumables, but it can be water consumable, cigarette pack consumable, food consumable that I showed you earlier, and so on. I also use basic transform, it's a local variable, just to spawn my element. As you can see, always spawning no collision. Actually, we do need this to have the element positioned in the world. And right after it is spawned, I add to my consumable object list this element so I can use it in my inventory. Then for all of the spawn actors that I have, I actually use set current quantity, so my inventory is restoring. Then the logic that you saw earlier, set actor enable collision for the spawned actors and hidden in game. I don't need to have them here. They will all be spawned in their 0, position. Whether they don't have any collision, they won't interact with each other, and I need them only to restore the inventory, and when I have the references from them in my play chapter, I can use the logic that is stored in this object. Then I use update pie menu, so my pie menu knows all the objects that I have, so I can select between all of them in the pie menu. Then the logic for currently, or actually yes, currently selects, or the last selected object. I use getClass and actually checks whether it's the same that I have in the stored data. So whether it's true, I update consumable widget and set active consumable. So when I load my game, my element is selected and I can use it. So basically this part of the logic is the same that we have here when we use add to inventory element. Update by menu, update consumable widget, checking the same element. So, and right after this, I use the boolean inventory ready. So it means that this event fire, everything works fine. Then I check whether I can actually start interacting. So I can use add to inventory events only when the inventory is loading. So I use this check logic in the event add to inventory and event remove from the inventory. Everything here is unchanged from the last tutorial. And actually that's all for the restoring inventory. Now we can talk about maybe weather system synchronization. So open weather system and we only need to change some options in the event begin play flow. So this one is the same. The only new thing we need to add is this part of logic. We use get current level and provide it as the local reference. Then we unpack the save data, break the structure of fgame data, and I use only level structure to save it to local reference. Then I break the structure from level data and use only levels time map, and I check whether current level we are right now is in our map. So whether it's true, the value from key I set as the current time, and whether it's false, so it means that we actually are the first time on our level, so we use the current time we have just set from our world outliner in our level. So when we load, we use the value we found in the map, and when we first time on our level, we use the basic time we have set. So that's all logic for synchronization weather. Also the time. So every time you save, you will have the proper visual look of your world with the correct weather, time, and so on and so forth. Now let's go to player start. Actually, you can skip this step, but I need to show you that my system is very expandable and you can have very big amount of various scenarios. For instance, if you want to have the transition right after some video about your game, so there have some changes and you don't need to use the inventory from the last checkpoint and your last attributes. For instance, if you remember Destiny, if you played Destiny, there are some levels then when you spawned, you have the ability just to walk. You can't run, or you have some different camera shakes. Your stamina and your health is a little bit lower, and so on. So you can choose how to start your level when you transition. So when you spawn, you have some kind of logic that you have created. And when you transition to a level, in developing your level, you can, by selecting this element, choose whether you need to load and carry your data from the last level into your new level and continue with this, and whether you have some gameplay changes, some plot changes, you can actually withdraw with your inventory and your attributes and start just like new episode. So for this I have actually this kind of logic. So if you saw my video, my early videos, I have this kind of logic. So when I spawn a player character, I have exposed some attributes I need to change. Right now it's this type of data, only floats, but I'll actually improve it and make it to structure, so I won't have this sort of spaghetti nodes. But nevertheless, let's continue. On the event begin play, we check whether we are in edited mode. So if we develop something, we don't need to store and load data. We need to only check how it will work. So I spawn player character with the basic elements that is actually editable from the world outliner. Then I store it as the local reference and possess to have control over this character. Then, whether I'm not in edited mode, so basically to have stored data in your game, you need to have edited checkbox unchecked and save your game. So you will actually have your save system work. So you load your progress, then you use get current level and store it as the local reference. Actually then pretty much simple logic. Break on game data, break on level structure, use levels transform, find whether we have the proper value for the key we are providing, whether we have it, we need to load, actually spawn our character in another, the stored position with the proper rotation, scale and so on, and provide, for instance, health and stamina from our save data. Then store player character as the local reference and possess it. So easy. But when we are first time spawned on our level, so it means we have transition for the first time, we don't have current level in the keys here, we use get actor transform, the position of player start actor in the level as the spawn transform. Then we check whether we have the new scenario. It's the one that I told you earlier. So new scenario means we need to start with some different kind of visual and gameplay feedback. So whether it's new scenario, I spawn the actor and use health and stamina, not from the same data. Here also I can select walk speed, run speed, and crouch speed also from the world outliner. Then store as local reference, possess, and this is the tricky part, I'll tell you in a moment. Next, whether it's not new scenario and we need to carry the data from the last level to our new level, we actually spawn actor, spawn our player character and use, for instance, current health and stamina from our save data. Then provide a local reference, also possess, and here you can see I have set timer by event, and the event is looping every 0.2 seconds. It's called check inventory. So the reason for this is when we actually have our inventory ready, we can actually save our game, because there is some situations when you transition to a new level and the save function fires before the inventory is ready, so your save data can be corrupted. So we need to check whether inventory system has inventory ready boolean set to true. Whether it's so, we need to clear and validate our timer, so this logic won't tick, and then only then we need to save our game. With this pipeline, your save game data won't be corrupted and your inventory will transition to a new level in a proper way. So that's all for the player start. It's not the ideal in the moment, but I'm developing it. It's very hard process, but I think you will like what I'll show you later. And now let's actually go to the Hud Main Menu. I forgot to mention one moment. We need to actually modify update by menu data, the function we created earlier. We need to add this kind of logic to load the game data and provide the proper logic for adding or removing the elements in our pie menu. So when I'll show you the difference, how it was from the last revision. On your left, how it was. On your right, how it looks right now. Nothing more changed, but we have some check whether active consumable is valid here. So it will prevent from firing some errors. And here you can see we have added the logic for loading our progress. So basically, update by menu data sets our last consumable. Then we need to load our progress, check whether our current class is the same as the one from this data, and if it's so, we set active element as our last consumable and just go with the default logic. Whether it's false, we don't need to set active consumable as the last consumable. The reason we check whether it's true, so when we load our game, we need this one to have the proper feedback from the user interface widget. So our element we use next, we use our selected element, will actually work in a proper way. I'm sorry guys for the explanation, a little bit hard for me right now, but I hope you understand the idea. And we are left with the advanced main menu system. So as you can see, I have made some changes, make some more elements to have the proper logic for creating new game, continue a new game, restoring default states of the settings, and restarting new game with overriding the whole progress. So let's continue. So let's start with our user interface, and the first element I need to show you is the enumeration for main menu state. It basically, we actually needed to select between which tabs we are transitioning. So from main to settings, from settings to maybe to the option when we need to restore our settings or we need to launch the new game and so on. Here it's some mix up. So basically main means the main menu, the main tab. Settings is for activating the settings widget, this one. Then the new game is actually for displaying the assistance message, this message. So it means that we are transitioned, for instance, from the main to new game, and whether we click apply here, we will actually start new game. So whether we click on no here, it will actually return to the main tab. So it's some kind of mixed state enumeration. And I'll show you the logic behind this right in a minute. Just take a look how I made it myself and the way I chose to create it is very suitable for me. Let's start with Gui Main Menu, the menu from the previous tutorial about main menu. Here you can see I have some changes. Right now I have 4 actually buttons. New game button. I renamed some of them, but the logic is actually the same for some of them. Continue button, settings button, quit button. As far as I remember, the basic behavior for all of these buttons is the same. Also, you can see right now, instead of having only GUI settings widget here, I also have the GUI assistant message. So, this one. Now let's create GUI assistant message and add it to our grid here. To add some custom widget in your main widget, you just need to search for it with the name of this widget, just like this, and drag and drop it under your canvas panel. So GUI assistant message is the message of choice whether we need to do one or another option. As you can see, it's actually some pretty tricky logic here. It has the background with the anchor of the whole area. So basically when we need to select between those options, all other elements, these buttons, should not be active. To prevent them from interaction, you just can create this kind of logic. It's the background with that fully covers the whole scene, but the alpha is set to 0, so it's invisible. And to provide these buttons from the interaction, your GUI assistant message element here, that order should be set to 1, because by default all these elements that order set to 0, and the higher the value is, on top they will be. So just like this. And as you can see, it has 3 spaces here and 3 more spaces here to have the proper layout. Assistance body is the border, which contains the vertical box for those elements. Then this one is the horizontal box for having those buttons here. The spaces set here to have the proper look, and as you can see, the size of all of them are the same. As for buttons, they have size field with the value of 1, and the behavior is the same that I have from the main menu. The behavior for the style. So when we don't hover on the button, it's invisible, and when we hover on it, we have some kind of outline. So take a look how I have set it. Maybe you will like the visual look of it. Also, to have this kind of visual style, you need to set the anchor of this widget to be on 0.5, 0.5 to be centered, and that's pretty much all. Also make sure that your buttons are actually set to be variable. The same goes for the main text. It's the text for the message that we will change due to the actions we are going to apply. So let's open our graph. Here we'll start with the event graph. Right now you can see that I have the main menu reference. It's our parent here, this widget. The reason for this, we need to synchronize between states we are selecting here and states we are selecting here. So in main menu widget on event construct, right after our function, we just need to get the reference of assistance message and set self, it means our widget, as the reference for main menu element here. Because main menu is created the first, this element will actually have this value valid. Next, as you can see, on apply button and deny button, I have actions on clicked, both of them, and also I have main menu state. It's the enumeration, this type that I just show you, and I check whether we are in the new game. We need to actually start the new game. It's the function which resets game data and open the first level, our chapter 1. Reset game data, it's the interface message that I showed you earlier. It's implemented in the game instance interface. And let me show you what it does. Game instance. Here, as you can see, I have, it's our game instance. Not only game data, the stored data that we are loading here, but we have some default game data. It's the unchanged type, unchanged data, the raw structure. So basically, we are overriding the game data in our save game data object with the default one, and then saving our game. So it will override our progress. So whether we press on apply, it means yes on the button, depending on the switch state we have here, and if it's restore state, we need to restore settings. It's actually the function in our it's actually the function that fires another function in our settings widget here. Because main menu has GUI settings widget here too, we can use it without any interfaces and just call the function that we need to implement. So open the settings widget, this one, and create function. Restore defaults, also create default settings. It's F settings structure, the same type of your settings here and here, but this will be an unchanged one. So restore defaults, we need to use apply game settings. It's the function we created earlier. It is stored in the function library. Actually uses two more functions, set global brightness and set global sensitivity, and we provide default settings and change structure, so it will override our current settings. Then we update our sliders, we restore them to our basic position 1 and 1, this one, and then we save game settings with our default settings, and that's all. So this function will actually restore our settings defaults. Next, when we are done with start new game and restore settings, here we need to set the visibility for our whole widget to be hidden, and we need to provide the previous states of our menu state to be settings. So let's actually go to main menu here, and I'll show you the function that is called set main menu state. As you can see, I have main menu state. It's main menu state here, this one. Actually, it's the renamed version of the previous enumeration type I had in the previous tutorial, but we have some new game and restore settings attributes, and I have the function which actually is fired through our assistance message widget to our main widget, and it's override the menu state we have here. So basically this function and the input here overrides our state here. The reason we need this kind of logic is simple. When we have the main menu, we are on the main state. When we press settings button, we change our state to settings. Then settings button is actually changed to another type of button, because we need to have some kind of button which will restore our default settings. So when we press the second time on our settings, it will actually change the settings to restore settings state. And when we actually apply our changes, we need to restore the default tab state. So from restore settings back to settings. Now let's see what do we have on deny button click. The same kind of logic, but from new game we restore the menu state to back to main, and from restore settings back to settings also. Then we use set visibility of our assistance message widget to be hidden. So the logic is simple. When we press apply, changes are done. We need to hide our widget. If you press no, changes, we don't apply changes, but we also need to hide our widget and restore the previous state. And as you can see, we are restoring it to our parent, our Gui Main Menu. Now, let me show you what we have here too. We also have, as you can see, main menu state. It's not only just variable, but it has rep notify. So when you change the replication type to rep notify, it has some uses in single player mode too, and it will automatically create the function on rep. And here we change the main text for our widget, this one. So whether we press on the new game, whether we press new game button, the text should be changed to some kind of this. Starting new game will delete your previous progress. And whether we are pressing on the restore settings, we have your settings will be returned to the default state. So make the same changes. And I think that's all for this assistance message widget, and we can move next. Our main menu. The changes we need to apply here. By default, assistance message here should be hidden as our settings. We only need to show it when we press the proper button. So let's go back to the event graph and see what has changed. We have new button, it's called new game. So when you press on it, we find new function, it's called new game. It sets the main menu state to new game. As you can see here, I have level data, and I check whether current level, the length of my map, doesn't equal 0. So when it's true, I need to hide assistance message, not hide, unhide. As you can see, I set it visible, and set main menu state in my assistance message with the current one, the new game. So it automatically fire the logic. Just wait. It automatically fire start new game logic, this function, because when you have rep notification here, when the value of the variable is changed, it automatically fire the proper function. Yes. Next, whether the length equals 0, it means we have no stored data. We just need to open our first gameplay level. In my case, it's chapter 1. Next, continue button. By default, continue button is set to be actually, when you don't have any just wait. I forgot to tell you about the construct function, the main function that is called when our main menu widget is fired. On construct, we need to set our main menu state to main. It's the basic layout. Then we load our game progress, and also check whether the length of our map equals 0. If it's so, we change the ability of our continue button to continue. So whether the length equals 0, our continue button, should be disabled. Whether it's the length isn't 0, our continue button should be enabled, and we can actually proceed with the last progress. Next, what have changed to here? Just like this. I set visibility depending on the switch state of game mode, not only for my game background, but also for the new game button. So when we go to the settings, I'm sorry, not to settings. So when we go and load our level, the ability to start new game will be disabled. We can start new game only from the main menu. So whether we are in main menu, we need to leave our new game button actually visible. Well guys, I'm sorry, I think I have made a little bit mistake here. It's some duplicated function. That's the way how it should actually look. So yes, whether we are in main menu, we need to change the text of our quit button to the exit. Whether we are in game, we need to change it to start screen. So logic for the quit button depends on the switch state of whether we are in main menu or in the gameplay level. This part of logic is the same as from the previous tutorial, but as I said, when we are in main menu, the new game button is visible, and when we are in our level, it is hidden. So do the same. Now back to the continue, and when we press on continue button, we check whether we are in also game or are in our main menu. So when we are in game, we just hit the widget, and when we are in main menu, we open our level. From the stored data we have here, when we load it, when our widget has been constructed. So we use checkpoint for this, and the overall logic is back to our player start. Next, settings button has updated settings function. It checks whether we are in main or settings tab. So we change from the main to settings. Then we need to show our GUI settings widget to be visible and hit continue button and new game button, so we don't need them to be appeared. And we need to change the text on our settings text button to restore to default. So it means when we press the second time, as you can see on click, will fire every time we click on the button, it will fire the same function. But when we press the second time, as you can see from the first time, it is set to settings, and when it's set to settings, it will actually set to restore settings state, and then we set main menu state in our assistant message to our current restore settings state here. And this will actually, as you see, will fire the restore settings function here. And depending on whether we press apply or no, it will fire back to our main menu here and restore the main menu state from restore settings to back to settings. So please look one more time. And the last is the quit. Pretty much the same, whether we are in main menu or whether we are in settings. So if it's main page, we check whether we show in our widget in main menu or in the gameplay level. So if it's main menu, we just quit the application, or if we are in gameplay level, we just go back to our main menu level, our transition level. Whether we are in settings, we need to hide our settings widget, then set visibility to continue button back to visible, because we are in the settings. Then change back settings text to be settings and set main state back to main. Then, depending whether we are in the main menu or game, quit text is set to exit or to start screen, and depending also on the state, we need to hide or make visible our new game button. So please take one more look. Well, that's pretty much all for the tutorial. I hope you like what you have seen. Please forgive me one more time for the last part of the video. I'm a little bit tired, but it's quite difficult to speak for this amount of time to explain everything. But if you follow my instructions, maybe when you press the pause button, you can actually achieve the same result, and I hope it will help you. Let me just think for a moment what I might have missed. Well, I hope nothing. So please leave your feedback, subscribe if you like my videos, and see you in the next year.